Okay, good day. So we do have a question here that we have. It reads, in the diagram, PQ is a chord of a circle with center M. PQ is produced to R such that QR is equal to PQ. T is the midpoint of PQ and MT is drawn. Prove that MR squared is equal to MQ squared plus 2QR squared. Now, what we need to understand here, we need to understand the ratios, like what we are having here. We have a line, which you can say is P to R. Then we have got Q here. Let's put Q here. And let's put T here. Now, what you need to understand is that we are told that these two are equal. PQ is equal to QR. Again, we also know that T is actually half of PQ. So when you are given something like this, you must know also that we are saying TQ, the distance of TQ is also, we have got, the line is what, TQR. So we know that to have PT, if you can say, or TQ is equals to half QR as well. Because you know that TQ is half PR, it also half QR as well. That's what you must also understand. So what you come and check here, you see that what are you having here? You've got MQ, you have got QR. Then what do you need to do here? You have to look at a bigger triangle, which is MTR. Then we are using Pythagoras theorem to say MR squared is equal to MT squared plus TR squared. But from this equation, from what we're having here, from this expression here, what we're having, we see that we don't have TR on our answer. We don't have TR on our answer. We also don't have PMT on our answer. So we must find a way to substitute these values. Now, what is TR in terms of QR? I want to express your TR in terms of QR. We also want to express MT in terms of QR. So both of these two, they must be expressed in terms of QR. So what do you need to do now? We know that your QR, okay, QR in terms of TR, what is it? Okay, let's have something like this. We know that we are told that this is half. So it means if these two are equal, it means that your Q is actually half of PR. So QR, if I can say QR is equals to half of PR. But now we find that if we are to split this, it means that we are having 1 over 4, 1 over 4, 1 over 4, 1 over 4. That's what we have here. To have, what is it? To have, what is it? To have TR, sorry, to have QR, we know that we are going to say is 1 quarter, 1 quarter, 1 quarter, 1 quarter. Is going to give us a total of what? Of 1. That's what we have from P to R. Let's just say that. Now, what about to have from T to R? What is it? From T to R, we find that if it is T to R, we can express it in terms of thirds. So you can say 1 over 3, 1 over 3, 1 over 3. So that if we are to say 1 over 3 plus 1 over 3 plus 1 over 3, we're going to get 1. So TR, we're not expressing QR in terms of what is it? So it means that from QR is 2 over 3, QR is equals to 2 over 3 of TR. That's what it means here. Is equals T over 3 of QR. And it means that your TR, which we are having here, is going to be 3 over 2. We're going to cross multiply with 3 over 2 both sides. It's going to be 3 over 2 QR. So now we have got a TR in terms of what? In terms of QR. What about MT? For MT, we need to take the small triangle, which is what? Small triangle, which is MTQ, which we are going to say, in that case, we're going to say MQ is equal to MQ squared is equals to mt squared plus tq squared. That's what we have there. So now we need to express your mt in terms of what? In terms of what is it? In terms of mq. So we're going to say mt squared is equals to mq squared minus tq squared. Okay. Now tq squared, what do we have with tq squared here? From tq, we have got what? TQ squared, we know that TQ is half of QR. TQ is half of QR, so we can express it in terms of QR, because we don't want this. We want QR, MQ and QR in our expression. So we're going to express this and say it's going to be MQ squared minus 1 over 2 QR in bracket, we square that. That's what we're having. So what do we end up having now? We're going to take this and add it to this. So it means that in terms of this TR squared is equals to therefore 3 over 2 in bracket QR squared, like that. Then what we're going to have now is that we're going to say MR, therefore MR squared is equal to MT squared. What is our MT squared? This is our MT squared. It's gonna be MQ squared minus 1 over 2 QR squared plus 3 over 2 QR in bracket squared. That's what we're having there. Then we are going to have MQ, MR, sorry. Oh, what did I put there? I put for a negative, equal sign instead of minus. Sorry about that. Oh, it's fine. Sorry. Then here, what are we going to have? Okay, MQ squared minus 1 over 2 squared is going to be 1 over 4 QR squared plus 3 over 2 squared. We're going to have 9 over 4 QR squared. Then if you have to punch in your calculator, to say negative 1 over 4 plus 9 over 4, you get 2. So it's going to be MR squared is going to be MQ squared minus, plus 2QR squared. So it's proved. Okay, it's proved like that. So guys, you need to be able to deal with what is the ratio. If you have to split whatever you're given there, because we are already told that this TQ is already half of PQ, of which PQ is equals to QR. So it means that TQ is also half of QR. So you must know that these are equal intervals. So you can deal with them whichever way you want. So if there are 4 of them equal intervals, you have got one, you are splitting into 1/4. If there are 6 of them, they're splitting into 1 over 6, 1 over 6, 1 over 6, each of them. Then you just count, all right, what is it? Like in this case here, we see that is 3, we are splitting this into 3 equal intervals. So we need to express TQ or QR in terms of what? In terms of TR, we see that it's going to be 3 over 2. QR is going to be 2 over 3 TR. That's what we have there. 2 over 3 of the what? TR. That's what we're talking about. 2 over 3, which is 1 over 3 plus 1 over 3, we get 2 over 3 of the what? TR. That's what we're talking about here. So if you have to add here, you get 1. If you have to add this 4, you also get 1. So that's what you need to deal with when you're dealing with what we call ratio. I hope you guys understand, and I also apply this in other problems. Okay, thank you so much.